Data is one of the most important parts of machine learning. Without enough of it, or proper data, it's very hard to make a good machine learning model. So what exactly is data? It is observations, or measurements, collected for several reasons. Data exists in many different forms. Cameras around us produce images and videos, our microphones record voices, and every letter, number, and symbol we write is an addition to the data that exists all around the world. All these are examples of data types that we can collect, analyze, and use for our different applications. A collection of data is called a dataset. Datasets are usually presented in tables, and these tables consist of two main parts, rows and columns. Each column represents a particular variable. Each row corresponds to a value for a given variable. Datasets can hold information such as social media users' information, bank statements, game scores, and much more. Let's take an example of a simple dataset represented in a table. In this table about football players, the columns contain the variables: age, height, maximum speed, and goals per season. The rows contain the exact data value that corresponds to each variable. For example, the variable age with the corresponding values of 33, 21, 25, etc. Variables can be categorized into dependent and independent variables. In our previous example, the goals per season depends on the player age, height, and maximum speeds. The variable whose value depends on another variable is called dependent variable. On the other hand, there is no relation between the age of the player and his height. Therefore, the value of age does not depend on the value of height. Hence, they are independent. As we have mentioned earlier, data is very important to any machine learning model. So how can we use data and datasets in our models? A dataset in machine learning is split into two parts: training dataset and a testing dataset. Training dataset is used to train the model, and then you test the trained model with the testing dataset and check how accurate the model output is. Going back to our dataset, we can give the model part of the data as training, and the rest is used for testing. The choice of how to split the data usually depends on the application and the project itself, but the choice of 70% training and 30% testing showed promising results in a lot of applications.